Assalamu alaikum, my dear students. My name is Shams Tanvir and I am from Rajaputra Model College, lecturer of Chemistry Department from English Medium Day Shift. And today I will uh, demonstrate the online video class for environmental chemistry for English medium. Uh, and this is from second paper. In the last previous class, we have discussed till until I think. Root mean square velocity, and we'll continue from the previous topic. So today we have topic about ideal gas and real gas. So which is ideal gas and which is real gas? Ideal gas is the gas which follows ideal gas equation, that is PV equals to nRT, and real gas does not follow ideal gas equation, but in reality no gas can follow this ideal gas equation. So that is, all gases are real gas. All gases are real gases. So technically this theory of ideal gas is a imaginary is an imaginary situation, and it's a theoretical concept. Practically it's not possible, but in some special cases real gas can behave like ideal gases. That is, if we increase the temperature, that it is at high temperature and low pressure, real gases can behave like ideal ones. So this ideal gas concept is very uh, obsolete. There are some mistakes. There are some factors which are not considered for real gases. So that's why ideal gas does not exist in reality. So we'll learn about why the ideal real gases deviate from ideal behavior. So there we'll see an example which is from French scientist Amaga. So he demonstrated an example that real gases does not behave like ideal gases, and he showed a proof. That is, he increased pressure for some specific gases, and then he drew a graph and took the information, and then he verified, and he found that the gases behave differently than ideal behavior. So he demonstrated a curve of gases which is called Amaga's curve. In this curve we are seeing that some gases, if we increase the pressure, then the PV value is decreasing and then gaining a sharp rise. So this is for carbon monoxide, methane, and ammonia. And for hydrogen and helium, they are increasing gradually. But for ideal behavior, the all lines should be straight for all gases. Yet we are not seeing any flat lines. We are seeing that some values are increasing gradually, and some are decreasing and then gaining a sharp rise. So this proof shows us that the ideal gases does not exist in reality, but in special conditions uh, it can behave like ideal gases, that is at high temperature and low pressure. So next we'll learn why the ideal gases behave, does not exist. That is why real gases does not behave like ideal ones. What are the causes? There are two causes of deviation of real gases from ideal behavior. First of all, defect is volume defect. That is, the volume is not measured properly, because kinetic theory in kinetic theory we have learned that the volume of the gas particles are very negligible, but in reality it's not true, because we can liquefy any gas at low temperature and high pressure. If we shake a can of body spray or a medicine, then we if we shake the can, then we'll hear a noise about a liquid is in the inside the container. But if we spray the canister, then we'll see that gases are coming out. So it's obvious that the gas spray gas is in the container in a liquid state. So that's why if we shake the container, then we'll see then we'll hear a noise about liquid something is inside the canister. So at low temperature and high pressure a gas can be liquefied, and the corrected volume is V minus NB. Then here B equals to a van der Waals constant. This is the correction of volume defect. And for pressure defect, there is a pressure defect, that is kinetic theory of gas. It states that the gas particles does not have any intermolecular attraction force, but if it didn't have any attraction force, it couldn't have been converted into liquid if we decrease the temperature and increase the pressure. So there is definitely an attraction force. For this reason, it can be converted into liquid. So there is also an individual pressure for gas particles. So the correctional pressure will be P plus N square A by V square, and the corrected equation will be like this. So this equation is real gas equation. If we consider these corrections, then if we can come to an agreement that real gases will also behave like ideal gas if we consider these corrections. Okay, so this is the real gas equation. And from this topic, then we'll discuss about nitrogen fixation, how a nitrogen is assimilated to animal from plants. So for fixation of nitrogen, first of all, the plant should uptake the nitrogen. How the plants uptake nitrogen? So we know that nitrogen exists in air, that is 70% of air is nitrogen. If lightning occurs in the cloud, then nitrogen and oxygen, it reacts to form nitric oxide, then oxidation occurs, and then nitric oxide turns into nitrogen oxide, nitrogen dioxide. This is a natural process. This is a very natural process. And then the nitrogen dioxide is absorbed by water, that is when rainfall occurs. Then the nitrogen dioxide, it converts into nitric acid and it falls to the ground. And then neutralization occurs when soil contains limestone in some amount. Then neutralization occurs and the nitric acid turns into nitrate salt. This nitrate salt will be uptaken by plant, and it becomes plant protein. Then if we or any animal eats the plant, then he gains nitrogen, then it becomes animal protein. So this is the fixation of nitrogen. Next one, we have come to the end of our chapter, and this is the last topic. So we'll discuss about gas, waste, and air pollution. How air pollution occurs and what are the components responsible for it. So gaseous pollutants. These are two types, that is inorganic products: carbon dioxide, carbon monoxide, nitrogen dioxide, sulfur dioxide, hydrogen fluoric acid, hydrochloric acid. These are gaseous pollutants. And there are some organic pollutants, that is hydrocarbons, aldehyde, ketone, that is amine, alcohol, etc. They are organic pollutants. And there are some particulate, that is dust, fog, sand, and smoke. Smoke means smoke plus fog, it means smoke. And there are sources of air pollution. How these impurities, air pollutants, generate carbon monoxide and carbon dioxide. They are mostly generated from burning of fuel and animal respiration and industrial stack gases. These contain high amount of carbon dioxide and carbon monoxide. Basically, carbon monoxide is produced due to incomplete combustion of any fuel. This produces carbon monoxide, and it is very much dangerous, and it creates asphyxiation to our respiratory system. And sulfur dioxide, it is produced from various fuel, burning of fuel from some industries, power station, coal burning, etc. This produces sulfur dioxide. And then we have nitrogen dioxide, nitric oxide. It is produced from urea fertilizer decomposition and some vehicles. That is, some fuels there is a small amount of nitrogen dioxide, nitric oxide, etc. They are produced. And we have volatile organic compounds from fuel burning. These are volatile organic compounds, and they contain carcinogenic material which causes cancer if we inhale or if we touch these compounds. And last, particulate matters from photochemical reactions and dust particles. They are the sources for air pollution. Particulate matters, these are the very much small particles which are not visible to the naked eye, but if we inhale these, they can cause some respiratory problems and many problems in our body. So these are particulate matters. So that will be all, and this is the end of our half yearly syllabus for our intermediate first year. Hope that you have enjoyed my classes, and if you have any questions regarding this chapter, these problems, you can ask me anytime. And there are there's a cell number given in the routine of your shift, so you can knock me and message me anytime. So that will be all, and till we meet, take care of yourself. So next time, see you everyone. Take care. Allah Hafiz.